So I'm very delighted to be here. It's always a pleasure to have an opportunity to come to UBC, to Vancouver. Even when it's rainy like this, it's still nice. So thank you for the invitation. And I'm excited to talk about automated discovery of social networks from social media data. I'm assistant professor at the School of Information Management and also director of the Social Media Lab. Just before I start briefly about the lab, you can find more information at socialmedialab.ca. But essentially, we are a multidisciplinary research unit as part of the school. And we're studying how people use social media, but also how social media changes the way we communicate and share information. We're also developing tools to analyze social media data. And so today I will be presenting one of the tools. And so those of you who brought your laptops, you can actually follow me with some of the exercise we're going to do later in this talk. Also, I would like to bring your attention to a special issue that I'm putting together with my colleague Barry Wellman from the University of Toronto. And the issue is on how do you measure influence on social media. This is going to be a special issue for the American Behavioral Sciences Journal, and deadline for submit your papers end of April. So you can go to our website, and it's under events, upcoming events, and find out more information about it. So if you're doing this type of research on influence, or you know somebody who is doing it, I encourage you to get in touch with us, because we would love to hear from you. All right, so this is the lab, but today I'm going to talk about how can we take all this information in social media and produce some useful social network representations from this data so that we can then analyze it in a more meaningful way. We know that more and more people join different social media networking websites. Facebook reports over 1 billion of users. Twitter reports over 500 million of users. So those are very impressive numbers. But what's even more impressive is that all these users contribute to these networks, and they generate a lot of data. So one of the main research questions that I'm trying to address here is how do we make sense of this vast amount of information in social media, and how do we gain timely access to relevant information to support decision-making processes. So to address these research questions, in the lab we developed Anatoliy, which is a tool to analyze different online communities. There are different ways to do automated analysis, text analysis, network analysis with online text. And there are different ways to represent this text visually. Today, due to time limitations, I'm only going to focus on the network representation. But I do encourage you to try other ways to represent online data. So the talk will be structured in 3 sections. First, I'll try to convince you why do we want to discover online social networks. Then we're going to talk about different methods to do so, starting from manual and going to more automated procedures. And then the last maybe 20 minutes I'll show you a demo of the tool, and those of you who with laptops can follow me. All right, so why do we want to discover online social networks? Well, it's interesting that according to some estimates, about 70% of user-generated data is essentially text-based. And it's really hard to essentially understand what's happening in an online community if you have to read all these messages one at a time. A more useful way to represent all this data would be to build meaningful social network representations. First of all, it will essentially condense the number of data points you need to visualize, but it will also reveal social structures behind this text. Because remember, this is user-generated data. So we don't want to read messages out of the context. We want to see who actually generated this message, where that person is located in the social network, and how that message influenced others in this network. So when we talk about social networks, we usually talk about nodes that represent people. It can represent other things, but for our purposes today, it's going to represent people. And we talk about edges, so lines connecting different nodes represent different types of relationships. So once we discover social networks, we can do lots of interesting things with it. We can build a more useful recommendation systems. And you all tried and experienced benefits of this. For example, on sites like Amazon, Netflix, you already getting those social-driven recommendations that are based on essential information about social networks, how people connected. If you like this item, you probably will like this item too. If you bought this item, you're probably going to buy this item too, based on some other users who are very similar to you. We can also improve information systems in general and improve essentially how we maintain our social connections. Facebook, LinkedIn, other social networking websites, a great example of how technology, information systems, using social network information can help us to maintain and manage much more social networks that we were able to do in the past. We can also use different browsing capabilities. And I know in your school, a number of researchers doing HCI type of research. And you know all these advantages of representing data in the form of networks. And I have examples here how news stories essentially being represented in the form of networks that allows you to explore what's happening in the world through interesting network visualizations. We can also talk about more secure and easy way to share information, or what we call web of trust. So essentially, if I know who are the people you tend to share files with, I can say, well, next time you upload this file to Google Drive, all of your friends who you tend to share this type of files with will also have access automatically. So, but that's only possible if we know information about social networks. Companies also increasingly interested in getting information about social networks for purposes of recruitment, finding experts, and of course marketing. And of course us researchers, we want to better understand what's really happening on the internet and social media, and answer questions such as how and why one online community emerges and another dies, how people agree on common practices and rules in online community, and how knowledge and information is shared among group members. So those are all important questions, and social networks will help us and do help us to answer those type of questions. So by now, I hope I convince you that social networks are great to have as researchers, as companies, and as individuals. Now let's talk about how we can actually discover those networks. Traditionally, to find how people connected, we would have to conduct a survey, a social network survey. And this is an example of one of the questions that you might want to ask people in the community to find out how they connected to other people in this group. So this one asks, it's based on online learning, and it asks, tell us, please indicate on a scale from 1 to 5 your friendship relationship with each student in the class. And then you have a list of students in the class, and you have answer, do you know this person? Is it just person in a class? A slight friendship, a friend, and so on. And this is just one type of relations that's out there. But you might want to ask about learning relationship, about socializing relationship, and so on. So the number of questions that you have to ask and the number of possible answers really makes such surveys very time-consuming. But also, it includes sensitive questions. So a lot of people are uncomfortable asking this type of questions. So quite often you might end up with partial information about networks, which is probably worse than actually not having information about networks. Plus, people answering, they come into the survey and answering the way they think the networks operates. So they can give partial answers, forget people and interactions, or perceive events and relationships differently. I think that person is my friend, but that person doesn't really think that I'm his friend. So the research, the task would be to automate this type of process of discovering how people connected in a community, and so that we can go from subjective metrics to more objective procedures. There are lots of data available on the internet that we can use to discover networks. Take it, the most easy to understand networks, email networks. We emails every day. We specify people we want to send our messages to, and that interaction creates a connection between us and those individuals. Forum networks, most of us participate in some form of forum. We reply to other people's messages. We comment on somebody else's message. So all of those interactions also connect us to other individuals. You have blog networks. You created a blog post. You link somebody else, says post to your message, and so you created a connection between two blocks. We also are well aware of friends networks, so those are self-declared networks on social networking websites, and we have networks of like-minded individuals where you don't explicitly say, well, this person is my friend, but you indicated your interests or preferences, and the other person happened to be interested in the same type of video or same type of picture. So we can automatically essentially say, well, there must be some kind of connection, potential connection between those individuals. So in my research, I'm really interested in the networks where there is no information about explicit or self-reported ties. So that excludes things like Facebook. But also, a lot of the time, even when there is existence of self-reported connections, sometimes the people behave and interact can show us and reveal more interesting dynamics. Again, they can declare that they're friends with hundreds of people, but the way they interact actually will indicate that this is the only 10 people that they tend to hang out with. And also, I mentioned earlier, there are lots of text-based conversations happening around the web. And so I'm interested in how can we use the conversational data to discover how people connected. And so what content-based features of online interactions can help us to uncover those nodes and then connections between nodes. So this is, for example, you have comments on a blog post. So can we convert and discover how people, who talks to whom in this sequential manner when they post messages to the blog? So again, going back to emails, just to show you basics of how we would go about discovering networks, and then moving towards more challenging environments. So emails, you have three individuals sending messages to each other, so you have nodes, and ties will represent who sends a message to whom. We can also talk about tie strength. Essentially, we can quantify it by saying, well, if these two people send more messages, then they have stronger ties than these two individuals. And so that's a basic concept. Emails are easy because, again, you declare in who you send a message to. More challenging environments, and that's what I'm interested in, is many-to-many forms of communication. Things like forum, mailing lists, chats, comment sections on YouTube videos, and Twitter as well. So how do we discover who talks to whom, who interacts with whom in those environments? A basic approach can be to look who they are replying to. So if it's an online forum, quite often there is information, I replied to this person's message. So what I call this methods chain networks. Let's look at this example. You have a message from Sam, and the previous person who posted a message in that thread, Gabriel. And the message said, Nick, Gina, and Gabriel, I apologize for not backing this up with a good source, but I know from reading about this topic that, and so on. So based on this approach, chain network, we'll simply connect the person who sent the message, Sam, to Gabriel, the previous sender. So that's our tie, one tie. But if you look at the text, there are other people involved in this interaction, and in particular Nick and Gina, who would be missed by this approach. So essentially we're missing potential connections between Sam, the sender of this message, to Nick, between Sam and Gina, and also because two people mentioned in the same sentences, they might be connected somehow as well. So we're missing, by not examining the content of the message, we might be missing some hidden patterns, hidden interactions. So the approach that I advocate for, I call name networks. Essentially, it's a simple approach, but it's quite effective. You don't even need to know who is the recipient or expected recipient of the message. You need to know who sent the message. So in this case, another example, Anne. And the text says, Steve and Natasha, I couldn't wait to see your site. I knew it was going to be awesome. And so now the next step would be to first connect the sender of the message to the people mentioned in this message. So in this case, Steve and Natasha. So you have two connections, and to Steve and to Natasha. And another option, you can also connect people whose names appear together in the message, Steve and Natasha. And then more often this particular situation happens, then you can increase the weight or strength of those connections. So if you see another message where Stephen and Tasha mentioned, you can increase the weight for that particular type. You say there is more evidence that these people somehow connected. So that's a simply name network. And the reason it works is if we look at the main communicative functions of personal names, well, literature tells us that they used to get somebody's attention, so identify addressees. This is what's missing in many of the messages, like comments. And also they are used to maintain and reinforce social relationship. If I'm more comfortable with a person, I will use that person's name, right? And the task, let's keep in mind, we're trying to discover social networks. So names can reveal those social relationships. Plus, on the web, names are one of the few textual carriers of somebody's online identity. And they're also crucial for creation and maintenance of sense of community. And that's what I'm really interested in studying. You have a group online. Is there a sense of community that emerges through that group? But the task of finding names is not easy. Well, there are some words that may be perceived as names, but they're not names of people necessarily, or can be names of people, but not necessarily group members. So we have to differentiate between names and recognize that some names here in this graph shown in red are names of the group members, and other names in this graph represent names, but not necessarily people belong to this group. So, for example, Chris was named, but it wasn't group member. Somebody just mentioned that person's name. Santa Monica was referring to public library. Dewey was part of the John Dewey sentences about philosopher and educator. And Mark referred to markup language. So we don't have enough time today to go into technical details how we can resolve this issue. But the approach we use, it's called name-alias resolution. All right, so this is just to show you how these two algorithms, so chain network and name network, can perform on the same data set. So think about a YouTube video, and there are lots of comments that follows that video. If you use chain network, who responded to whom, you can get this type of representation of interactions. So there's one comment after another. There is no obvious interactions between group members. So kind of noodle here. And we may think that there's nothing really interesting happening in that conversation. But once you actually try to connect who mentioned whom, who is mentioned with whom together, there is more interesting social structures are emerging. And here you're now starting to see there's a cluster that it's somewhat disconnected from a general group. So perhaps that group either disagree or agree with the video, but that's the minority opinion. There's also within that cluster, you can see some people are taking more leadership role, some on the periphery. So very interesting what we can learn through that type of networks. So any questions so far? All right. So I'm just going to check time. So we're doing good. And so in my own thesis work, when I was trying to develop and test this name network methodology, I was also comparing it to chain networks and self-reported networks. And what I found that structurally, that name networks and self-reported networks, so essentially how people perceive interactions, are more similar than self-reported and chain networks. So which is great. It means that if you don't have access to self-reported data, you can use name network as an alternative. Just briefly, I'll show you a case study how I use name networks to study one of the online communities that emerge on a particular blog. So this is a blog of a popular blogger who posts messages about real estate, and Vancouver is one of the main subjects of this post. And essentially, it's Garth Turner, and he thinks there's a huge bubble. So he talks about money, real estate, economy, and so on. But what I was interested in is, can a blog support the development of an online community? And how do we know that if a community has emerged among blog readers? Because we don't think about blogs as a community support or maintenance platform. But yet, this particular blog attracts hundreds and hundreds comments after each blog post. And so to answer this type of questions, I turn to two theories. Virtual settlement, proposed by Jones, which says that to have an online community, you first need to have a virtual settlement, and some of the characteristics of that would be a common public place for people to meet, presence of interactivity between people, and also sustained membership. So people who posted today, they stayed around for a while in this community. So once you establish that there is a virtual community, or virtual settlement, then you can examine if there is a sense of community. And then I turn to Macmillan's and Chavez's theory of sense of community, which wasn't designed for online community, but since then, since 1986, it was adopted and validated with a lot of different online communities. So essentially, the theory says that people should have feelings of membership and be able to influence others in the group, and the group should allow them to reinforce of their needs and share emotional connections with each other. So there are different ways to test this type of characteristics of online community. I'm not going to go through a lot of details, but essentially the point for today is to show you how I took the comments after the website, after each blog post for a period of time. And you can see a lot of comments. This particular WordPress website doesn't allow threaded discussions. So as a result, people post one message after another. But what's interesting that they do mention each other's by usernames. And so name network approach was very relevant to this particular data set. So I took a snapshot of this community for all of the posts in October 2008 and then in January 2009, and you can see network representation of this group. I also wanted to know, what are the stronger connections that exist among these members. So I removed all of the people and connections if they only mention somebody else once. So I only kept connections when they exchange at least 3 messages, 3 interactions. And so those pictures represent these closer connections in this network. So we can see October, it's early on in this community, there's one main node in that center that holds all the conversations. So imagine that that particular person not participating in the conversation anymore. Community doesn't exist. But then in January, more people started joining this blog, and the number of messages grew, the number of unique posters grew, and the core group developed as well. More people took a leadership role in this group, and essentially it started appearing like an online community, which is here. I probably wouldn't call it as online community, and you see why. So this is just an example in one study how we can mine those social networks, online social networks, and see what's really happening online in different environments. So now I will show you some demo, and I will encourage you, if you have your laptops with you, just to follow me. And we will look at some of the networks we can discover from listservs first, and then Twitter second. Before I go to start the demo, any questions so far? Yes, please.
Curious how the discovery tool you deal with structural equivalence. So if they all mention someone else, it's not appearing as linked connections, right?
Give me an example. So all people mention the same person?
Yeah, so people mention Bob, and they talk about Bob, but Bob never communicates with them, so they're all structurally equivalent, because they're all talking about the same thing.
Right.
They might be talking to each other, but just not addressing each other.
Yeah. So in this case, they wouldn't be connected because they didn't mention each other's name, but they would. But you will see in the graph that they are connected to the same node. So from that perspective, you'll see indirect connection. Yeah. What we also did that we built a lot of expert functionalities, ability to export network data to other social network analysis features. And so essentially, Anatoliy is a tool to collect your data, to start exploration, text-based and network exploration, and then you can do more advanced social network analysis functionalities in other packages. because we didn't see there's a need for us to compete with well-developed packages. So in those packages, you can do a little bit more advanced things, what you mentioned earlier. Yeah. Okay, very good. So let me switch to my browser. All right, so if you can go to netlytic.org, and I encourage you after today's presentation to check out some of the case studies that we've done and my students done. For example, a recent thesis work by Jennifer Gregg Martin. She looked at the online fan community, the OneRing.net, the community that talks about Lords of the Ring series and also the book, the Tolkien's book. And she was trying to examine how people perceive the story if they read the book first and then watch the movie, and the other way around, if you watch the movie, and then read the book. She also was interested if you, read the book, are you more likely to watch the movie, and the other way around. But that's her published thesis work, math thesis work. We also have done a lot of different studies using Twitter data sets. This one will link you to a series of blog posts on our website. Talks about Canada Games in 2011. But what I want you to click, if you follow me here, there's a button that says Tour the System as a Guest. And there are two data sets that are already available for you to kind of explore the system and its functionalities. So let's start looking at the mailing list data set. And this is just a sample of messages from a particular internet listserv for the Association of Internet Researchers from November 2008. Because today we're only focusing on network analysis, I'm going to skip the first couple steps and go to step number 4, network analysis. Well, actually, I'm going to skip that too. I'm going to go straight to visualization. And so in visualization, I'll select the data set I want to look at. And if all these steps are completed, so text analysis, network analysis, you'll see some of the charts that tells you a little bit more about the community. So who are active posters of the group, what are the patterns of posting, what are the most frequently words they use, and so on. But what I want you to show you, so if you follow me, click on View Interactive Visualization. And and so that's what we will see. First, it will start by. So first, visualization will start by showing you top 10 kind of most connected users in this group. And this is done so that you don't feel overwhelmed to see all of the nodes in this network. Again, this tool is designed to start exploring a particular online community. So you start with something. You start with most frequently used words, or in this case, most connected individuals. And so if you see there's a circle around a particular node, it means that other people connected to that particular individual. So you can double-click. So for example, let's click on Charles here. Charles is. Just going to move this person back. And so let's look at a couple features of this visualization. You have ties, connections in different colors. The black color represents this, what I mentioned, chain network. So people exchanging messages with each other. And the blue connection represents somebody is mentioned by name, so name networks. And you can also look at each network individually. This is a kind of final visualization which merged two networks to give you more context and more information. Also, you can notice that size of each node is different. So size represents how many people that particular person connected. For example, Barry Wellman here, one of the members of this group, appears as a large node. It means that if you double-click on that node, there will be others connected to that person. But there's also a question mark in the middle of the person's node. And the reason is because Barry Wellman didn't post any messages during the sample that we collected. So keep in mind, this is for just 1 month in November. But what happened, somebody else replied to his earlier message that maybe from October. but the system registered and essentially gives you more information whether people, posted during this time period or not. So now you want to explore why these connections exist. And if you click on connection at tie, it will show you a window, and it will show you all the messages that exist between individuals. Here you have only one message from Charles to Verman, and this is a snippet of the message, and you can click on it and read the full message. So it was one reply to Verman. If you look at the message to Naomi Susan, it's blue color, so represent it's mentioned. Naomi was mentioned by name. So if you click on the tie, you see there are two messages from Charles, and in both times Naomi was mentioned. That looked at Naomi, Berens, and so on, and thanks to Naomi. So then you can click. This just shows you a snippet where Naomi was mentioned, and then you can click and read the full message where she was mentioned. But clearly, it wasn't direct interaction, but she was mentioned twice. That's why there is a connection between Charles to her. So this is how you would start exploring this type of networks. You can also use a time filter built in, essentially seeing what are the first connections that emerge in, and just drag this filter, and it shows you how connections emerge over time. There is also age filter. Remember, I introduced the notion of tie strength, and this particular one just counts how many times somebody is mentioned or replied to. So here, you can also filter out. So in this particular group, there are no what we can call strong ties. People only mention each other one time, so that's why you don't see any messages. But you can say see all, essentially see all nodes. And it will start building a network and remove labels. And in that network, you'll see that some people mention each other more often, so maybe there is a stronger connection exists between them. And in the same fashion, you can use time filter to see how this network was growing over time. All right, so this is a listserv data set. You have clearly replies to, and you have people mentioning each other's names. But you can see that so green connections represent the reference by name, and blue represent chain networks, and the black represent when both of the cases happens at the same time. There are only a few cases. Actually, one case right here. There's a black tie here between two individuals. But in the listserv environment, you can see that the overwhelming majority of conversations happening in the fashion of reply to. But if you only want to study kind of name networks, more personal interactions, then you can remove the blue nodes and just look at the green connections. So let's look at the Twitter. And now, so we can log out as a guest. So we're going to do a little bit more interactive way. I will ask you to either create an account with Netlytic, or you can use your existing Google or Yahoo account to log in. I think it will be easier if you use something that you already have. And we use an essentially open ID to log you in. Using your Google account, we're not storing your passwords for those sites at all. We just use them to authenticate you. But essentially, so I logged in with using my open ID, Google. And first, it shows me a list of data sets that already available in my account. So Caroline mentioned the workshop and the forum on healthcare and social media that we attended earlier today. So I've been collecting messages from Twitter using this hashtag. And this sign indicates that it's still collecting messages. And we can the system can automatically collect messages using certain search criteria every hour. What I want you to do, so anybody needs any help with logging in? Those of you who are following us? If you logged in for the first time, the system will invite you to import your new data set because you're not going to have existing data sets. So that's fine. Okay, I'll give you a second to log it in. But what we're going to use, we can go, and collect messages from RSS feed, from Google Docs. We found that more and more researchers rely on Google Documents to keep their research data, including interview transcripts and spreadsheets. So you can import data directly from Google Docs. There's a Twitter collector. For that, the system will ask you to connect your Twitter account to be able to get messages from Twitter. And this has to do with the limitation as to how many messages you can collect from Twitter. And so this means you're going to use your own limit of your own Twitter account instead of using a communal limit, which will disappear very fast if we all rely on the same account. A new feature, YouTube comments, that we're currently testing. So this is a prototype. And text files. So a lot of data is still in the form of text files. You can have a chat conversation, and then you want to each line represent a message. So you can import it through that way. You can have an Excel spreadsheet, and you can import it as a comma-separated value file, CSV file. You can have a listserv or some kind of transcript of one message after another, and the system will be able to recognize where one message ends and another begins. So there are lots of different formats. So in designing the system, we envision it that people will use to analyze a wide variety of communities, not just communities that are popular now, such as Twitter. All right, so what I want you to do to import one of the public data set that I made available for this workshop, just to practice, instead of us collecting a new data set. So let's go to public data sets, and let's use a sample of Twitter messages from September last year that mentioned London 2012 Olympics. And so if you click on the London 2012, there are some available interactive visualization already available, and some details about this particular community exist. But what we want to click is to import this data set. What will happen is a copy of this data set will be copied to your file so that you can do whatever you want with it, to your data sets, to your account. So I clicked on it, so it's now in my data set. Go back to home, and so this is where it appears. So those of you who follow me, okay? Managed to do it? Because we want to only focus on network analysis, let's jump to step number 4. Select data set. And so it will appear at the end. Well, it's going to be the only data set that is available to you if you haven't used this system before. It will show you 2 potential options that we talked about, chain network and name network. I don't suggest to use chain network approach for Twitter data set, because Twitter, essentially, we're relying on what we call search API to gather all the messages that follows certain criteria. In this case, all of the messages that contains hashtag London 2012. So that type of data, Twitter doesn't give us structural data of who replies to whom. So in this case, as I mentioned earlier, chain network information is not available. So we have to rely on name networks. As you can see, there is some data already appearing because I already analyzed it before and shared this data set with you. This data set, I'll increase font a little bit here, has about 1,100 people posting it, but only 74 connections. So even not visualizing it, I can tell there's nothing, no communal interactions going on. Not a lot of connections relatively to number of nodes in this network. And this is kind of makes sense because this was a sample of Twitter messages that included hashtag. And the whole world had been tweeting on London 2012, so it's not surprisingly that for a very short period of time we got random messages. It's actually surprising that we did find some connections within that random sample. But it will do for the practice for us. The system also tells us that it found 162 names. But what I want us to do is to say clear names. We want to do it from scratch. So I want you to experience this as if it's a new data set that you just collected it. So let's clear names. It will say 000, number of unprocessed messages, 1152. Now let's hit analyze. So it's going to be processing each message, looking for names, personal names, and also usernames. And at the same time, once it's processing the messages, it will also find who mentions whom and people who mention as well, who I mentioned together. While it's running the cycle, I just want to show you there's also see more processing options. And by default, it will not include people who are not part of this group into the network. So, for example, in previous example, there was Barry Wellman who appeared in the picture with question mark. So that person did not post any messages for that sample period of time. So for that case, I said, yes, please include all of the people you find mentioned, but even if they didn't post any messages to this data set. But sometimes people can talk about celebrities or politicians, let's say President of the US, Obama. And so the question is, do you want to include these type of individuals in your network, in the analysis? And it all depends whether what types of analysis you're conducting. Sometimes you do want to include people who are being discussed by others, and sometimes you don't want to. For example, we analyze fan communities of different TV shows and movies, and people quite often mention characters, names of characters in the discussions. So you can actually see whether certain groups of people like or prefer to talk about certain type of characters. So in that case, you might want to include those names. No. The other option I want to show you here, connect names mentioned in the same message to each other. And this one, if you remember when I talked about name networks, and two names appeared. I'm actually going to jump to that example, just to remind you. Two names appeared in the same message. Here, Steve and Natasha in this case. So that question, do you want to connect Steve and Natasha or not? Again, depends on type of analysis you conduct. If you collected a small data sample, especially from social media, and you suspect that you might not get all of the messages, just sample, it's good to use all of the evidence that's available in your current data set to create those connections. Because quite often, in your sample, it can be a forward, a retweet of somebody else's message, and there can be a lot of people mentioning that message. And because you don't have original messages in your data set, maybe you started collecting data too late, but you still want to collect those evidence about social ties, you might say, yes, please connect all of the names that are mentioned in the same message. But there is also option here. You can connect all names or only names in the close proximity. It doesn't really apply to Twitter messages because they're so short, 140 characters. But if we think about blog posts or longer piece of text, sometimes it's important to say only connect people who are mentioned, let's say, in the same sentences, right? Versus if I mention one person at the beginning of my message and the next page I mention somebody else, this is not an evidence that they are somehow connected. Okay, so now that process is finished, we have similar stats. Now we can visualize it. Visualize that network. And again, it will start with only most connected individuals here. And we can double click and explore this network a little bit more. And so on. We can also say see all messages. See all connections. So the network will show you this network. And you can see there's no really core group in this conversation, but there are some kind of islands, clusters here, cliques. And these somehow connected. They may be following each other. I'll remove labels just to see the structure of this sample. So this particular star configurations, these probably popular Twitter users and cliques. It's possible they followed each other on Twitter, or they maybe followed a conversation that somebody started, or they followed a hashtag. And that's the beauty of using someone like name network type of approach when you're not restricted by kind of self-declared connection. I follow this individual on Twitter, so then we connected. Well, I maybe follow that person's messages, but maybe I just ignore that person. But this actually shows you the interactions. I replied to that person's message, retweeted it, and so on. And you can click on any of the ties, connections, to see the actual message that happened between individuals. And so this is the tweet. Now let's do an experiment. So by default, I said, do not connect people who are mentioned in the same message. So I'll say connect people and see the number of ties right now, 66. Let's reanalyze it. And the number of connections went up. So it means that the system found that there are some messages where people were mentioned in the same message. So essentially, we expect to see a generally same. So if I say see all messages, it's going to look very similar, plus a few more connections. But what will be even more interesting if we say include people. So I'm going to say again, connect all names that are mentioned together. But let's also include people who are not part of the group. So let's click reanalyze. And this is the last experiment that we're going to conduct here. And so you can see the number of nodes went up. So it means that some outsiders who are mentioned were part of the network. The number of ties also went up. If you want to know who are the people who were included, even before clicking the visualize, you can click on the number of names found. And this is the names, personal names, and sometimes if it's the first and last name mentioned together, shows you as a tag cloud. So the size represents how often a particular name mentioned. So Boris, you can click on the name Boris, and it'll show you all of the tweets with the Boris. So you can explore a data set in this way. And then you can say, okay, this shows you top 30 individuals. You can increase the top 50 and so on. Tag cloud. But I think it's more fun to study community through network perspective. So that's why we want to visualize it. Again, it's going to start with top 10. And so, for example, here, Rafael and Oscar, those are names of players, football players. These are not Twitter users. But Chelsea, this is actually not a name of a player. So it's a news. So it says Brazil lead by 1 goal scored by Rafael, and it's assist of a new Chelsea's player Oscar. So Chelsea is a name, so that's why it was included automatically in the network. Then now you as a researcher need to decide whether Chelsea as an entity is deserved to be as part of this network or not. Is it important? If you think it's not, what you can do, you go back to this tag cloud of names, and you find Chelsea, this is it, in this tag cloud, and you correct the automatically discovered name. You say, well, it's name, but I don't want it to be in this network. And just reminds you that you need to reanalyze network to see the changes. So I'm going to hit reanalyze. Let's just make sure we use the same characteristics, reanalyze. So we're only essentially removing one node from this network, Chelsea. So instead of 1145, you can confirm that 46, now we have 45. And we can also confirm that visually. So you have Raphael, you have Boris, but there's no Chelsea. And also you can look, there's a list of all of the nodes here. And you can show what we call eager networks of people in this network. And you can confirm that Chelsea is not, it's not on that list. And this is eager network essentially. You pick a person you want to zoom in and focus on that particular person's interactions instead of looking at the whole network, and you just explore that person's connections. So these are some of the things you can do with online data, text-based data. And there are different, as you can see, ways to visualize and represent this data in the form of networks. So I just want to remind you that as researchers, we have to keep in mind that there are so many different options, and every time you make certain steps, you have to justify your steps. So I encourage you to try it, system, and let me know if there are data sets that you want to study that currently you might not be able to import. We'll be happy to help you with that. Or if you want to see new ways to visualize data. I also want to show you a preview of new network visualizations that my lab is currently working on. Essentially, we're moving towards the age of big data. All these communities, we're not talking about 100 people networks, we're talking about million people networks. And so as a result, this is a web-based application, so Anatoliy. There are not a lot of libraries that can handle and visualize lots of dots in the network. So now, and primarily a lot of dots don't recognize touch screens, which we're moving towards as well. So a lot of desktops, tablets are now touch screen, and it's much easier to essentially navigate through a network using touchscreen gestures. So to address this type of issue, we're developing new HTML5 type of visualizations. And this is just a preview of what we're working on. And so this is a HTML5 visualization that responds on touchscreen activities. But it also, there's an additional bonus that it automatically recognizes different clusters and subgroups of people in the network. So it kind of will tell you, well, these people tend to be connected to each other versus that group. So giving you additional analytics. So that's coming later this term. All right. I think we have just a couple minutes for questions.
Okay, we'll open up the floor to questions.
So that was fun. Thanks for the demo, Anatoliy. When you do the calculations of the networks, have you found that the results that you get are deterministic or are they probabilistic? So in other words, if I'm replicating your analysis and you're testing hypotheses about the development of online communities, would I be able to replicate your findings?
Mm-hmm. Well, you should be able to replicate if you're using the same data set, the same period of time that you're looking at the community. Because as we know, community structure changes over time. So if you're looking at my paper that reports about the blogging community in 2008 and 2009, and you're looking at it now, it's definitely going to look different. There will be different people. So first step, it has to rely on the same data set, the same communal structures. So secondly, because it's all automated, so we're relying on a more objective way to find those structures, you will be able to produce the same network structures. Now, so that's the second question, using the same algorithm to produce the structure. The third step, once you have the same structure, the question is, how do you, prove or validate that this is community or not? And there are different ways to answer this question. You can go and interview some of the people in the community. You can conduct survey. You can use different theories as well. So I mentioned already coupled theories, sense of community and virtual settlement. And so depending on what kind of theories you're relying on and what methods you're using, you may come to different conclusions, for example. And then I will invite you to have a discussion. So based on your evidence, do you think it's a community or not? But what I can tell you that if you're relying on social network analysis by looking at this community, and you're relying on more or less established metrics, such as density, clustering, so you can generally agree with me based on my conclusion using the same metrics. So does it answer your question?
It does. I'm surprised.
Yeah?
Quite frankly, because some of the clustering algorithms that I've worked with are only probabilistic, not deterministic. So that you have different results, different structures of the network, depending on, each time you do it. So,
but you're talking about clustering. Here I'm talking about discovering a network. So you're talking about these colors. So these colors are different based on different algorithms. And here we can play with different, different algorithms, and the colors will be different. So that changes. But what I was presenting today is the structure. So the structure, the connection will remain the same if you follow the same procedures. And then if you use the same social network analysis metrics, such as centrality, clustering, density, you will get the same values. So we have to come to the same conclusions if we rely on the same metrics.
So these are statistical measures. So most of the statistical measures are probabilistic. So have you tested it? I mean, have you run a series of experiments to actually evaluate the results?
Yeah. So that's where it's an excellent question. I'll be happy. I know some of you have to run, so please don't.
Very interesting.
I'll be happy to chat with you more. I love the question. So what I'm saying that this validation part can take different forms. The paper, the case study I showed you in the blogosphere, based on the theories of sense of community and virtual settlement. For each theory established certain characteristics that should exist if you can say, well, this is a community. So then as a researcher, I look at the literature and see how other researchers quantified or tested those factors or presence or absence of those characteristics. And so I follow, particular testing model. You can say, well, I don't believe in those theories. And then you say, well, I actually want to go and interview these folks and say, ask them, think there is a sense of community or not. So there are different ways to validate, what we get automatically and from social network analysis versus what other people think, other community members think. And in my studies, I'm trying to triangulate and use multiple methods. So for blogosphere, we haven't really used self-reported networks. But for other studies, learning networks, I mentioned earlier, we actually compared what we get in automatically with what people think, so self-reported networks. So then you can make judgments whether, what people think is more likely to represent what it is. Because you have to also keep in mind that if you interview or survey a person right here, the perception of this individual will be different about the community from person here. So this person will say, well, yes, definitely, we have a community. And look, because that person feels it's happening, everybody talks to that individual. But then you talk to somebody here and say, well, no, I don't think this is a community. So then we can discuss, well, how did you do a sampling if you, started doing more qualitative approaches, like interviewing people. And when we talk about online communities with hundreds and thousands of actors, it's really impossible to do, to collect reliable self-reported data. So then, of course, we talk about sampling. Yeah. But
small numbers too.
Sorry?
There's the problem of small numbers too. So the smaller the sample, the more stochastic, the more variable the results potentially. So you have some potential for sample error. And I don't know, against a population of self-selected individuals, how representative you would necessarily say that is. If you can analyze the entire so-called population, I suppose then you can treat that as an entire population and you're not really analyzing a sample. But then you've got the problem of, does this really represent a community? So yeah, trying to surface kind of the boundaries of how much we can rely on this kind of analysis, and it kind of goes to the question of, are we the sum total of our representations, and also the limitations of these kinds of methods, both in terms of the underlying computations and then the visual projections of those computations.
Well, so
Saying briefly, we are at 5:03, and I'd be delighted to continue the conversation for as long as Anatoliy wants to, but perhaps we could take maybe 30 seconds, and if people need to move on to other things, then they're welcome to do so, and we are happy to talk for...
So I'll be around, so I think we need to finish the recording, but I'll be happy to chat with you. I know somebody has more questions, so thank you.
Okay. All right. Thank you very much. All right.